Hello everyone and welcome to another HSMA solution video. Now today we are going to be going through exercise 1 of session 1G, that's the third and final Python programming session in HSMA 6, and this session starts off by looking at classes. Now we have been asked to create a class of a patient. We've been given 4 attributes that this patient will have, so that's the name, their ID, their age, and whether they've been cured or not, and we've been asked to write 2 methods. Now remember, a method is basically just a function that is attached to a class in some way. So the methods we've been asked to add are attends ED or attend ED and receive treatment. We've been given some descriptions for what each of these methods should do, and we've been also told that all attributes, so these things here, of the patient are provided at instantiation. That just means when we create a new patient object, we will be expecting the name, the patient ID and age to be provided, whether that's a user inputting them, whether that's pulling from a database of some sort, whatever that means. Effectively, when we create a new patient, we will be providing those values. However, the cured attribute, which is just a Boolean value, a true or false value, should default to false for all new patients. And then we've been told that once we define that, we're going to create some sample patients and try this class out. So the very first thing we're going to do is create our class. We are going to start by typing in the keyword class and patient. So we're going to call this patient, that's what we're going to call our class. We could call it patient class, but that's a little bit redundant. We could call it my hospital patient. Any of these are fine. Nothing wrong with any of those. You get to determine what you call your class. Now, what we next need to do is define the bit of code that will run when we first set up a new patient. So every time we go later into our code and say, please create patient Mr. Smith, who's got an ID of 423 and is 34 years old. So when we run this later on to create a patient object with these attributes, this little bit of code that we're about to define will run. I'm going to get rid of Mr. Smith for now. Actually, I'm going to pop him inside this comment block here. So this is just a comment, a multi-line comment. You can see we've got 3 quotation marks at the top, 3 quotation marks at the bottom, which means that all of this code will just not run. It's commented out, it's ignored by Python in this Python file, and that is great because it just means we can keep track of what we're actually meant to be doing. So, patient class, what we're going to do here is, as I say, define the code that runs at the beginning. Now this is just a special little bit of code that you need to remember. It's def, so remember when we did functions before, we used this sort of, so defined my function, then we passed in what the arguments would be, and then we did something here, effectively, whether that was printing, whether that was doing some calculations, but so on and so forth. Just the same for inside this class. So we say def, and then we have 2 underscores. For me, that's shift and the key to the right of my 0 in the top line of keys on my keyboard. So 2 underscores. Then we want init, initialize effectively, and 2 underscores again. We are then going to open brackets, and we're going to first pass in this special parameter called self. Now, you don't need to worry too much about exactly what self is. Just remember, you always need to pass it when you initialize a new, when you use this init method inside your classes. And we'll be passing it around a little bit later on as well, and I'll explain a little bit more as we get to that, why we are using self and why we are sometimes not using self. So, self, and then we are going to say, coming back to this thing where we said about certain attributes being provided at instantiation, so when we're sort of initializing this class, we are going to expect someone to pass in a name, a patient ID, and a patient age. Now we're going to end this with a colon, so remember when we did functions before, we needed to end with a colon, and then we will need to indent everything that comes after that. And notice that we also indented this def init method, so we had class patient and then we indented this code. That's because this almost effectively belongs to the class of patient. So First thing we're going to do is self.name equals name. We're also going to do self.patient ID equals patient ID. And we're going to do self.age equals age. Now, that all looks a little bit strange and quite repetitive and redundant, so why are we bothering to do that? Effectively, what we're saying is please pass in these three things to this patient and add these as attributes to the patient object. So what I'm going to do a second is I'm going to take Mr. Smith out of my bit there, and I'm going to actually create Mr. Smith. Call him test 1, and I'm going to print Mr. Smith, or test patient 1 even. I'm going to print his name. I'm also going to print his age. And actually, let's just turn this into an F string instead. So remember our format strings, these are a nice way of mixing Python variables and bits of code with, well, effectively with text, so that we can have nice outputs without having to do too much additional work. So patient name is, and then we're going to say he's however many years old he is. So is that correct? Oh, I'm missing a close of curly bracket there. And I'm now going to go up to my top right here, and I'm going to choose Run Current File in Interactive Window. Now what you can see happens is it's just connecting to my base kernel, and it has printed out patient Mr. Smith is 34. So what's happened here? Well, we've gone, please create me a patient object. Please say that the name here, that we're passing in here, is Mr. Smith. Please then assign a name attribute to Mr. Smith, to this patient that we are creating, in this case test patient 1. So every time I ask for the name of test patient 1, which is what I'm doing with this dot name here, please tell me what that patient's name is. If I were to have test patient 2, and I were going to run patient Mr. Smith, let's say Mrs. Bobson, and she is patient ID 142, and she is 21 years old. So this time I'm just going to copy this test patient 2, test patient 2 age, and you can see very quickly we can start to build up these little bits of these little repetitive units that we can do very similar things to, very repetitive things to. We could iterate through all of our patients in a list, for example, and pull out the name of each patient, the age of each patient. We start getting this very standardized structure that is easy to reuse and is very useful when we have these units like a patient, that we might want to have the same attributes, the same things. It's a bit like someone walking around with a clipboard that says name, patient ID and age, and they've got a clipboard for every single patient. So the self part effectively just means please attach it to myself. Please attach it to this patient class. We could actually pass this as name input, patient ID input, age input, and actually that would still work as long as we put on the right hand side of this of these arguments patient ID input, age input. This is effectively just saying please make self.name whatever we have passed in here, name input, and so on. So if I run this again just to demonstrate, you will see it still works exactly the same. However, the kind of standard seems to be that actually we just pass them in a little bit like this. So call your attributes what you're going to call them when you pass them as arguments to init. So patient ID and age input. So just to recap that, from the start, we have created a class called patient. We have defined the code that will run when we first create a patient. So we create a patient like this. This just says please create an object of class patient, and here are the things I'm passing to you to do with it. So self.name is name, self.patient ID is patient ID, and self.age equals age. Now, the next thing, we've been told that we also want to have an attribute called cured, but we are not asking the user to pass that in. We will assume that every patient who turns up, so let's say that we've got an emergency department, we wouldn't expect people to turn up already cured, although unfortunately that may sometimes be the case. So self.cured equals false. So all we're saying is for every patient that we pass in, we're going to say that this patient is not cured when they arrive, when we first create them. So I can't pass anything else in here now. If I try passing in false, I'm just going to get rid of Mrs. Bobson a second, just so we can focus on our lovely Mr. Smith. And I'm going to say, and cured status equals test patient 1.cured. I'm going to make this a second line of my print statement here. Don't forget I need to tell it that this is also an F string, and I need to just make sure I've closed all my quote marks. So yeah, this is now a multi-line print statement that will just make our lives a little bit easier so we can see what's going on. So patient so and so is this old, and their cured status is this. So I'm going to run my current file in interactive window, and you can see it says patient in it takes 4 positional arguments, but 5 were given. Well, what are our 4 positional arguments? It's self, which gets passed automatically. We can ignore that entirely. Name, patient ID, and age. It's telling us we've passed 1 extra argument, 1 more than it is expecting, because we are not meant to be specifying what the status of cured is. So if I run this again now, I've just got rid of that extra argument. And you can see this time it says patient Mr. Smith is 34 and the cured status is false. If I were to change the default to true, then I could run this again, and you can see that this time patient Mr. Smith is 34 and cured status equals true. I could change this to not cured. I could make it a string. Absolutely fine. We can make our default arguments whatever we want. But what matters is that they are set up for every single patient. So if I were to copy this again now for Mrs. Bobson and bring her back in, so test patient 2, I'm just going to make sure I go through and change it to these different test patients. I'm going to run the current, and Mr. Smith is 34 and he is not cured, and Mrs. Bobson is 21 and she is also not cured. So I'm just going to save that a second. Right, so we've set up our attributes. We've set up all 4 of these attributes. We've got the name is a string, we've got the patient ID, we're expecting an integer. We have got the age is going to be an integer, and cured is a boolean. And you'll notice as well, we haven't explicitly specified anywhere that these attributes that we're passing in have to be those things. Python does not enforce that. You do not have to explicitly state that name must be a string, the patient must be an integer. You can write in some of your own checks. You could create some conditional logic that makes it so that the class won't create if people have not passed in the right kind of parameter, but that's a bit beyond the scope of the exercise today. So what we're going to do next is we're going to define methods. So we've got attend ED and receive treatment. Now, a method, like I said before, is just a function that belongs to a class. They're effectively exactly the same thing, but the benefit of them of belonging to a class is that they can quite easily access these attributes that we set up without us having to pass each and every one of them in by, from scratch. We don't have to pass in name, patient ID, and age. We can just pass in self, and then the method can access all of these things, including self.cured. All of these can be accessed at once without us having to do lots of additional passing around of variables, which is very powerful, very flexible, especially once your classes start becoming bigger and more complicated. So I am going to start defining a method called attend ED. So I'm going to pass in self, and I'm also going to pass in mean time. So we've been told in the attend ED method, I'm just going to move this over a little bit so we can see better what's going on. In the attend ED method, we've been told that we should randomly sample a time for the patient to remain in the ED from an exponential distribution based on the mean time that is passed in. So we are expecting a user to pass in how long on average does it take someone in our ED to be treated. So we will, this is not coming when we, it's not defined in our class anywhere, it's coming from outside. It's being passed in as an argument. So that's quite significant in a minute when we start passing around self and using self for some things and not for others. So that's just why I'm calling attention to it here. Now, to sample from an exponential distribution, use the expovariate method of the random library. So that tells me I need to import the random library at the start of my code. So what am I going to do? So we want to use the expovariate method of the random library and pass in 1 over the mean, which will return a randomly sampled value. So for now, all I'm going to do is I am going to create a variable called randomly sampled time, and I'm going to make it what was it, random.expovariate, there we go, and it tells us that we're passing in a parameter called lambda. It doesn't really matter what lambda is at this point in time. All we know is we've been told to pass in 1 minus our mean time. So I'm going to do 1 minus mean time here. And what does this mean for us? It means that we will, well, what I want to do here, I want to print this randomly sampled time, just so I can demonstrate to you what's going on. So I'm not going to print Mr. Bobson and Mrs. Bobson and Mr. Smith. I'm going to run instead test patient 1 dot attend ed, and I'm going to pass in a mean time of 5. Now let's break this down a little bit. So you can see we've taken test patient 1, we've got a dot, and we've got the name of our method that we've created. Now, if we were calling a function, it would look something a little bit more like this. So we'd be passing in a mean of 5, and we wouldn't have all this dot and stuff between it. All this is because it's a method, it belongs to the object. So we have test patient 1, please use, and this dot just means please use the attended method that belongs to test patient 1. And test patient 1 is an object of class patient, so it has access to the attended method. And any patients we do this for will have access to this as well. So Mrs. Bobson can have her own time. We can pass in the same mean time. We can explicitly say that we're passing in the mean time, or we can assume it. So when we pass in a variable without saying what exactly it is, it just matches it up and says, oh, okay, it ignores self. Don't worry about self when we're passing variables around. All you need to worry is make sure you put self at the beginning and then put any of your other variables that you want the user to pass in to the method after it. And that will match up to mean time, the first argument that you have specified after self. But I'm just going to put in mean time equals here just to be a little bit clearer about what is going on. So I'm going to clear my terminal over here just so we can keep track of what's going on a bit better. So if I were to print out now, I'm going to run this current file in interactive window, you can see that we've got a mean time of 5 has been passed in, and a test patient as well of attending ED has had, oh, and I did 1 minus mean time. That's supposed to be 1 divided by mean time. That's why that is giving us negative times that people have spent in. So I'm going to clear that. Let's try that again. That would make more sense. So yeah, this time you can see that actually we've got test patient 1, and we have said, please randomly sample me a time. That is, and you don't really need to worry too much about the specifics of what this is, but effectively it will rely on this average time. It creates a distribution, a probability distribution, around which we will sample a time that is somewhere within the realms of possibility based on what the average time is. We go a lot more into detail about what distributions are, and we'll give you some much better explanations and more accurate explanations at a later date. But for now, we've basically said test patient 1, so for Mr. Smith, please work out how long Mr. Smith is going to spend in ED. Well, that's going to be 8.7374 minutes. And Mrs. Bobson, we've done it again, and this time she's only spending 4.6 minutes in. So we're getting a different answer for each of those people. If I were to run this again, you can see we've got different times again, and so on and so forth. We can do some clever things to make sure that actually it's a little bit less random than that. So if we did want to run a simulation where the first patient always has a time of so and so, and the second patient always has a time of a different time, but we want to run the same simulation with different parameters, just to see what the impact of that is, then there are ways of doing that, and we will cover that in the second module. But for now, we just find that each time we run it, we get a new randomly sampled time. So what do we need to do with this randomly sampled time now? We just need to return this value, and the method should also print the method should print how long they were in ED4. So I am going to, instead of just printing randomly sampled time, well, actually that's all we needed to do, but we could just tidy this up a little bit and say, message given the patient's name, their ID, and how long they spent in the emergency department. Well, actually, to be honest, I can probably just adapt this a little bit. This code that we were testing out, and you can see I've pasted it in here. I just need to get rid of this green, so this little hash symbol, which, because I'd commented out that code a minute ago so it wouldn't run. I'm just going to press the tab key a few times and then the space key a few times to get this to line up nicely, just so it's easier to keep track of. So patient, and this time the important thing is we use self. So patient self.name, what was it? I'm going to say ID self dot, make sure we put that in our brackets, so self dot patient ID, and we're going to say it was in the ED for our randomly sampled time. Now let's take another look at the mixture of whether we are saying self or not self. So here all we're saying is please look at, so patient self.name, so look back at the attributes that this patient has and put in self.name. So it's going to be Mr. Bobson in our case in a minute, and we're going to look for their ID, and then we're going to say that they were in the ED for randomly sampled time. Now, randomly sampled time exists within this method. It doesn't exist outside of this. It's not one of these attributes of the patient. It's not a self dot something. It is just something that we have temporarily created as part of the attend ED method, and therefore we do not need to specify. We don't put self in front of it because it won't be able to find it. The attribute randomly sampled time for the patient doesn't exist. It's just a temporary variable inside this method. I'm also going to choose to return the randomly sampled time, just so that if we want to use it later in a different part of our data, then we can actually do that. So this time now, when I run test patient 1 attend ED, I am going to get some outputs. So we're going to see that patient Mr. Smith was in the ED for 8.4 minutes. Patient Mrs. Bobson, ID 142, was in the ED for 12 minutes, or sorry, not 12 minutes, 0.012 minutes. Now, see why this is so powerful. We've just created these patients once, and we haven't then had to be passing around. We haven't had to say into this attend to ED, we haven't had to say we need to pass the name, patient ID. Actually that's all just being handled by the fact that we're passing self. That saves us so much time when we start getting to more complicated stuff. Other thing to note is because I have saved the randomly sampled time, I'm going to say that actually let's save the time for Mr. Smith, and then I'm going to just print time times 50, just so that you can see actually we've got access to Mr. Bobson's time, not Mr. Bobson, Mr. Smith's time. See, so we've got patient Mr. Smith ID was in for 1.81 minutes, and actually if we times that by 50 we also get 90. So we could do whatever we want to do. We could store that somewhere else, like a list of let's say a list of times, if we wanted to be keeping track of how long people on average were spending in our emergency department across lots of different patients. So it's quite powerful. Right, we're getting there. We've just got one more method that we need to define. So this time I'm going to define the receive treatment method. And again, you're probably getting used to this now. We're going to pass in self. and we're going to pass in the probability of a cure. So we've been told, I'm just going to get rid of this interactive window a second so we can see a bit better. We've been told that received treatment should randomly determine if the patient is cured or not, based on a probability passed in. So again, we are expecting someone to pass in, to make available to the method what the probability of a cure should be. That is not defined anywhere in our patient class. We're going to use the uniform method or the random library to sample a number between 0 and 1. We're then going to compare that number to the probability to see whether or not the patient is cured. If they're cured, we update the patient's cured attribute, and then we print a message indicating whether they were cured or not. So let's have a look at this. So I need to be having a look at let's say the randomly sampled cure prob, or randomly sampled, let's call it randomly sampled success. I can't spell success on a good day, but let's hope that's right. So we are going to use, again, the random library. This time we are going to do the uniform. And the great thing about the uniform distribution, or the uniform thing, is that actually we can say that if the so the first argument is a random number in the range A to B, or A B. So the square bracket just means that it could include that value. The round bracket means that it probably won't include that value. It won't include that value. So theoretically, it's a little bit complicated, so we won't worry about it too much here. But effectively, A is our lower bound, so we're going to say we want a value between 0 and we want a value between 1. So somewhere between 0 and 1. Now, actually, due to rounding, the number that we get theoretically probably will never be exactly 1. It could, however, be, again, because of rounding. Don't worry about it too much, but basically for the purposes of this exercise, random uniform 0 to 1 is absolutely fine. Now I'm just going to print the randomly sampled success so that we can have a look at what this will look like. So I'm just going to press Control and / that will comment out this line for me. Very useful little feature, because if I press that again, Control and / it uncomments. So I find I comment and uncomment code a lot while I'm debugging, trying things out, seeing how things work. So let's run test patient 1, and we're going to run the received treatment model method even. I'm now going to run this in the interactive window, and it's told me, of course, I'm missing one required positional argument, the probability of being cured. Now actually at the moment I'm not using this. I don't actually ever make use of it in these couple of lines of code that are part of the receive treatment method. However, we have told the Python that it should be passed in. So I'm just going to pass in 0.3 at the moment, 0.3 chance of that treatment being successful. So what we are seeing here is that effectively we're getting a random number, and here we've got 0.39. And if I run this again, we get 0.12, run it again, we get 0.16, 0.3, and so on and so forth. So the easiest way to probably think about it is, let's actually separate it up into almost into 100 separate bounds. So, what's the chance of getting a number between 0 and 0.01, 0.011 and 0.02, and so on. So there's an equal chance of getting all of those. If you ran this 100,000 times, you would get roughly equal numbers of numbers falling within those boundaries. Now, it's a little bit hard to explain, but what we want to do effectively is check whether the number that's being generated is less than the probability of being cured. Now, what does this mean? Well, if we've got a probability of being cured, 0.3, so our probability is 0.3, if I treated 100 people, 30 of them would be cured. Now, if I run a random sample 100 times, a random uniform distribution, roughly 30 of the numbers I get will be below 0.3. So that kind of matches up to the probability of being cured. If the numbers over that, so the remaining 0.7, that is effectively the chance of that's what's left. So what matters for the code, the purposes of the code, is that the randomly sampled treatment, the chances of being cured need to be, we're checking, oops, sorry, that's completely wrong there. We want to check if the number we've sampled is less than the probability of a cure, then we will change self.cured to true. So at that point we're saying, okay, if this condition is met, if this number that we have generated is lower than the probability of the cure, then self.cured becomes true. So let's do this. I'm going to create Mr. Bobson. I'm going to treat him, and I'm also going to that. What did we need to print? It was something along the lines of, if they're cured, the patient's cured attribute should be updated appropriately and a message should be printed indicating whether they were cured or not. So if they were cured, I'm going to update self.cured to true, and I am also going to run a print message that says, so what we've got, self.patient ID, or let's say self.name, and we're going to put in brackets, that's what their ID is, so ID blah, was cured. So if we're inside this condition, if we're inside this indented block, that must mean that they were cured because the randomly sampled number was less than the probability of a cure. So we are going to say that self.name was cured, and I am going to say we cure the probability of, and make this a new line, an F. Again, I want this to be an F string, so this is just so that we're not going over the limit here. The probability of being cured was, and I'm going to put in the probability of the cure, which the user will have passed in, and I'm going to say please make it a percentage that is rounded to 2 decimal places. So 2 decimal places, that's this little bit in here, and make it a percentage. Now, if they were not cured, so our else statement, if this wasn't met, then let's say we'll copy this out again, and we'll say that the patient was not cured, probability of being cured was this. Now, let us have a look at this. So self.cured equals true. So yeah, let's just remind ourselves that this bit will run if the randomly sampled success is less than the probability of the cure, and self.cured, this attribute belonging to patient, will get updated. If they are not cured, self.cured does not get changed. We don't have any code relating to that attribute. It doesn't update, it stays as it was. So let's treat a few people. Let's treat Mr. Smith. So I'm going to run that current file in interactive window. Actually, let's clear this all out so we can see a bit better. And you can see that Mr. Smith was not cured. The probability of being cured was 30%. Let's, if I click this play button again, he was not cured, so that's 3 times he's not been cured now. Oh, he was cured this time, so that's 1 time. 4 times he wasn't cured, 5 times he wasn't cured, 6 times he wasn't cured. He was cured, so they were up to 6 times versus 2 times. So you can see that it's generally, oh, he was cured again this time. So it is random, but more often than not, he is not being cured. And I can probably make this more obvious if I get rid of that. And I'm going to clear this out. I'm going to run it again. So I've now put a very low probability of being cured. So I'm going to run the current file in interactive window. He wasn't cured. Wasn't cured. Wasn't cured 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times, 12 times, 13, 14, 15. You can see that there is a very poor chance now that poor Mr. Smith is being cured. And actually, we have not cured him once yet, poor guy. We're having a terrible time. He's really having a terrible time of it. And finally, he has been cured. So you can see there really is some randomness to this. It's not perfect, but it is pretty good when you start getting to extremely high numbers of patients. So there it is. We've created our class. We have done all of the things we've been asked to do, and we have tested it with some patients. Now, I'm just going to try and do something here just to demonstrate to you why this works so well. So this time I'm going to create a list of patients. So I'm going to create a patient list. I am going to, actually no, let's go for, we create an empty patient list. I'm going to say for I in range 10,000, create a, add to the patient list a patient. We're going to make their, we're going to call them all patient by their name. So we're going to go patient I, so that's going to be their name. We're going to say that their ID is going to be a random integer between 1 and 67,000. And their, what was the other thing we needed to pass to our patients? Their age. So we're going to make their age a random number between 1 and 100. So if I were to now have a look at this patient list, I'm just going to get rid of these lines where we're trying out Mr. Smith. So we're going to print the patient list. Now this is going to get very long, so we'll see how well this goes. And why is patient, oh, it's all wrong. Patient list dot append. That's the important thing we've got to do. I am basically saying, please create a new patient object. Here are the parameters I'm passing into you, and then please append this to this list. So we're going to have a list full of these patient objects. So yeah, you can see actually if I clear this and run it in the interactive window, we have got a list that's not the most user-friendly and intuitive, but that is because, and I've just realised this has gone off the side of the screen slightly at some point, so I do apologise for that. That's because each object in here is a patient object. So actually we've got our first item in the list of patient object, after this comma we've got our second item in the list, and so on. Now, if I were instead to go, I want to print a list comprehension, so I'm going to go for patient in patient list. I am going to ask for the patient age. So patient.age for patient in patient list. Clear this out, run it, and you can see suddenly we've got the age of every single patient that we created at random. I could do patient.name. I'm going to run this current file in an interactive window, and actually I forgot to make that an F string, so that's why that hasn't worked. If I run that again, so we can get patient 0, patient 1, all the way up to patient however many tens of thousands we asked for, or 10,000 in this case. I could also run the something like this, so I could do, I think I haven't imported NumPy, so I'll do that in a second. I'm going to import NumPy as NP. I'm actually going to put that at the start of my code, because that isn't, you're meant to do that. I'm going to run the current file in the interactive window, and you can see now that I've worked out that the average age of all our patients is somewhere around 50.35, which we'd probably expect because we asked for a random number between 0 and 100. The median, again, somewhere around, well, exactly 50. So you can see that we can start to do some very large-scale calculations on, in this case, these simulated patients that we've created. This will come in very handy when we get on to our discrete event simulation model, where we are quite often simulating patients, service users, anything along those lines. Now, what else can I show you about this? Well, let's have a look at the number who have been cured. I'm just going to comment out at this point, I don't want this print statement happening for 10,000 people, so I'm just going to get rid of that. And all I care about is whether these patients get cured or not. So I am going to try and cure these patients. So I'm going to run for each patient the received treatment method on them and see what I get out as a resulting list. Because remember we said that, oh actually no, we'll have to do 2 steps here. I'm going to run the current file interactive window. Oh, and we needed to pass in the probability of being cured. Let's make that 0.3. And actually we can see we just get none back in each of these cases. That is fine. That's not a problem. But what I will need to do is I'm going to make sure that everyone receives the treatment, and then I am going to actually look at whether they are cured. Let's run this again. And you can see now we have gone through and said, please give each and every patient in our list of randomly created patients, give them some treatment with a chance of 0.3 of that treatment working. And then let's print whether the patient has been cured. And see, we've got false, false, true, false, 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 and so on and so forth. So some patients have successfully been treated, some have not. The next thing I'm going to do, I'm just going to show you, if I wrap this in int, so I'm saying please turn these true and false values into integers. Why am I trying to do this? Well, let's run it and I will show you. So now we get lots of zeros and lots of ones. Now this is great because I can do numpy sum, and you can see that I get 3093. So what does 3093 mean? Well, for every person who was cured, for who this value was true, turning it into an integer returns 1. Turning it into, if it's false, turning it into an integer will return 0. So what we can see is 3,000 out of the number of people that we created, 10,000, were successfully when they received treatment, they were cured. If I change this to 0.5 and run it again, we can see we get 4,925. If I change it to 0.7 and run it again, then we get around about 7,000. So again, there's a little bit of random variation if I run this multiple times whilst not changing the value. 7,021, 6,966, 6,951, 6,952, and so on. There is a little bit of variation around the average, but that is to be expected because of randomness. There is inherent randomness in the way that this is being calculated. So that's going above and beyond what the exercise was asking for, but this is just to demonstrate to you some of the ways in which we can take our patient class objects that we've created and do some really cool stuff with it. And you will really enjoy seeing more of that in the discrete event simulation module.